Hello everybody, this lecture is about oxidation reaction of aldehyde and ketone functional group. Give you an example, an aldehyde could be oxidized to the carboxylic acid. Here, oxidizing agent including the following. Jones oxidizing agent. What are Jones? Chromium trioxide in sulfuric acid, SNS, okay? And other oxidizing agent including potassium permanganate under basic condition. To remove that accidental. And usually you would oxidize aldehyde to the corresponding carboxylate. And then in a separate step, you need to protonate the carboxylate into the carboxylic acid. Okay. Another oxidizing agent are silver. Even very weak oxidizing agent like silver oxide could oxidize aldehyde into carboxylate, followed by protonation to prepare the corresponding carboxylic acid. Show you one very interesting example. The D-glucose is this guy. Oops. And for D-glucose, it's primarily exists in this cyclic hemiacetal form. So carbon number 1 is an hemiacetal. It bonds with a hydroxide and alkoxide. Okay, if we finishing up our numbering, this is D-glucose. And D-glucose is a reducing sugar. The reason it's called a reducing sugar is because it's a reducing agent, or it could be oxidized. So for D-glucose, we can write out its acyclic form. Right? This aldehyde could be oxidized by silver ammonium complex under basic condition, generating the corresponding carboxylate. This carboxylate could be further be protonated, generating gluconic acid. Okay, same stereochemistry. And feel free to identify R or S for these chirality centers to help yourself to refresh about how to identify R or S. And the byproduct is silver, which could form a very nice silver mirror. Okay, so this reaction is very helpful to identify aldehyde or any reducing sugar. This particular reaction is often referred to as Toland's test. Another interesting reaction associated to aldehyde and ketone are that they can be oxidized to the corresponding ester. For instance, acetophenol could be oxidized by a peroxy acid. Let's use a general peroxy acid over here. And essentially a product like this, it's a phenyl acetate, could be generated with a byproduct of the carboxylic acid. The reaction occurs with multiple mechanistic steps, and then in the first step, and the oxygen could be protonated under acidic condition, and eventually a very important reaction intermediate is a tetrahedral reaction intermediate. So the peroxy acid with a oxygen over here, which act as a nucleophile attacking on the electrophilic carbon, eventually you generate this tetrahedral reaction intermediate. We're talking about this particular carbon, converting from a sp2 to sp3 tetrahedral reaction intermediate. And for this carbon here, after a number of mechanistic steps again, and this tetrahedral reaction intermediate could be deprotonated, and the electron between oxygen and hydrogen, I didn't do a good job, is shifted over to form a carbon-oxygen pi bond, and this carbon-carbon bond, the electron carries this phenyl group and is broken to form a carbon-oxygen bond. At the same time, this carbon-oxygen bond is broken, and you're generating a very stable leaving group. And there's really multiple mechanistic steps eventually lead to the formation of the corresponding ester. And this particular reaction is generally referred to as the Baeyer-Villiger reaction. The tendency of which group tend to migrate is referred to as the migratory aptitude. The migratory aptitude is in the order of hydride, followed by a phenyl anion, followed by the alkyl anion, and in the order of tertiary, better than secondary, followed by primary alkylide. And therefore, if your hydride is migrate, and you would eventually generating the corresponding carboxylic acid, but if you have an alkyl or phenyl or other carbon content group migrate, you would generating the corresponding ester. The peroxy acid that's used for the Baeyer-Villiger reaction is often the metachloropurbenzoic acid, abbreviated as MCPPA. And this is a reagent we have seen before, right? We have used MCPPA to prepare epoxide when reacting with alkene. So now you can add one more reaction for this nice perbenzoic acid reagent that it can be used to also conduct Baeyer-Villiger reaction. So that's all about the oxidation reaction of aldehyde and ketone.